All right. Hockey. All right. All right. So this is either going to be very, very hard or very, very easy. I have not found an in-between for it yet.
So that means it's going to be very, very.
So some people either really like probability or they really hate it. So I'm going to try to make it as easy as possible. Okay. We'll see how it rolls. All right. So we need to talk about first random experiments in sample space. A random experiment is any activity whose outcome cannot be predicted. Okay. So, in other words, if I have a deck of cards, I can't predict that you're going to pull out the 7 of clubs. I can't predict that you're going to roll a die and it's going to land on a 4. Unless it's weighted and we know it's going to land on a 4. But any type of random experiment, I can't tell you what's going to happen. Okay? So, these are the types of things. Tossing a coin. I can't tell you if it's going to land on heads or tails. Okay? We talked about dice, cards, results of a game. I can't tell you who's going to win. Okay? Forecasting the weather. I said the weatherman has the best job in the world. Okay? He can be 100% wrong and still keep a job. Lucky him. Okay? So, what you need to be able to do with sample space is 1, give me the sample space. List all ways that this can happen. So your sample space is a list of all outcomes. Okay, so when they're asking for S or your sample space, you need to list me. It can happen this way, it can happen this way. I want a list of every way that it can happen. Okay, when they ask for the size of the sample space, this is how many outcomes. So in other words, here I'm looking for an actual number. Okay. Here I'm actually looking for a number. As always, we are going to practice. So, the first one, I'm tossing a coin once.
It can land on heads or tails.
It can land on heads or it can land on tails. That's your sample space. What can happen? When I flip a coin, it's not going to land on red. It's not going to land on green. It's not going to land on a 5. It's going to land on heads or tails. So those are my options. How many options do I have? 2. So that's your sample space size. What are my options? How many do I have then? Okay, number 2. I'm tossing a coin twice now. So what's my options? Okay, I can get heads or tails. What else can I get?
Tails,
Tails, tails.
heads, heads,
Heads, heads.
tails.
Tails, heads. Okay, so I can either toss a head first, tail second. Okay. Heads first, tails second. I can get 2 tails. I can get 2 heads. Or I can get a tails first and heads second. So that's my sample space. So what's my size?
Is it 4?
It's 4. Okay. Each one of these. 1, 2, 3, and 4. Okay, so you don't necessarily count the individual flips. Okay. Take a look at this one. The multiple choice section of a quiz has 2 questions. Your answer choices are A, B, C, and D. What's my sample space? A, 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 B, A, C, A, D, B, A, B, C, B, D. What are you missing with your B's? B, B, C, 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 A, C, B, C, D, 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 A, D, B, D, C. There's 16. Okay. The more things that I throw in there, the harder this becomes. Okay. A student must answer 3 true or false questions on a warm-up.
True, false.
Careful, you're doing 3. So true, true, true.
Oh.
Okay. So, whoo! Let me show you what you learned in elementary school to help you out. You remember doing a tree diagram?
Yeah.
You can use that. So, my first question. What are my options? True or false? So I've got option 1, which is true. Option 2, which is false. Those then branch off to my next question. So my second question. So if I answered true first, I can answer true second or false second. If I answered false first, I can answer true second or false second. We've got one more question. So off of each one of these, we can branch out again to our third question. So again, my options are true and false. True, false. True and false. So, if you follow from the first question to the third question, I can do true, true, true. That's my first option. I can do true, true, false. That's my second option. I can do true, false, true. That's my third option. I can do true, false, false. That's my fourth option. Those are all of my options that start me with true. Then I've got the same thing going on with false down here. I can go false, true, true. I can do false, true, false. I can do false, false, true. I can do false, false, false. So these are your options, and there are 8. So if you struggle with listing out the sample space, don't be afraid to use a tree diagram. Okay. I get a lot of people that say, I'm not using that. That's elementary. Why? Who cares? Who cares? If you get the answer right, do you care? No. If you get the answer right, do I care? Nope. Okay. I don't care. All right. A couple plans to have 3 children and considers whether they may have a boy or a girl. Okay. This question is really no different than what you just did. Okay? You're having 3 kids. Kid 1, just like question 1. Kid 2, just like question 2. Kid 3, just like question 3. And each one of those, you've got 2 options. You're either going to have a boy or a girl. So my sample space size is still 8 here. Okay, you can branch it off just like you did with the other one. So we can have girl, 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 boy, girl, boy, girl, or girl, boy, boy. Those are all of my options with a girl first. Then we do the same thing with boys. So we can have boy, boy, boy. We can have boy, girl, boy. We can have boy, boy, girl. Or boy, girl, girl. Sorry. I lost my train of thought there. Boy, girl, girl. Okay. So you still have 8 options. It's just instead of talking heads and tails, we're now talking boys and girls. Okay. Okay. Rolling a pair of dice simultaneously and considering the total of the 2 die. Okay. So if I'm rolling 2 die, what's the smallest number that I can get? 2. You get snake eyes. The smallest I can get is a 2. Can I get a 3?
Yeah.
What about a 4?
Yeah.
We can do 5. When do I stop?
Once you get to
12. Once you get to
12. Why do I stop at 12?
6
No,
and
no,
6.
no.
6 and 6.
6 and 6. Each die has 6 sides to it. So 6 and 6. So there are 11 different options here.
Will you be here for this? Guys, your history test isn't until.
Number 7, Sarah, Kristen, I don't know, Arlene, I don't know how you want to pronounce that, are running for class president and vice president. What is my sample space? Think about it this way. If I put Sarah in as president, who could go with her? Krista. Or I can have Sarah and Arlene. Can I have Sarah and Sarah?
No.
Why?
Because it's
So the same
It's
person.
the same person. You can't run 2 different things. Okay? So these are Sarah as president and Kristen Arlene as vice president. What else can I put up here?
K and A.
Krista and Sarah,
Krista.
Krista and Arlene,
A and K, and then A and S.
A and K, and A and S. Okay? So here I only have 6 options because I can't repeat a person. Okay? If Sarah is president, Sarah cannot also be vice president. Okay? She is one person. We're not cutting her in half. We're not sawing bodies.
We can.
We could, but I don't think Sarah would quite be all there.
She'd be halfway there.
She'd be halfway there and dead. But we'll work on it. Oh my goodness. Still there. You're right. All right. So the last thing we need to talk about in this section, because I don't like to say this, but y'all suck at cards. I don't know what it is. Y'all not play like blackjack,
We are
solitaire.
teens in this century. We play Uno cards on our phone. On our phone.
You don't play solitaire on your phone? Because I still have solitaire on my phone.
That's what
Okay, well, my problem with probability is y'all don't know what the heck's in a deck of cards. So
I do.
I gave this to you first. First off, there are 52 total cards.
Yep.
Okay, 52. We're not counting the jokers.
52 pickup. That's my
52 pickup. That's right. Okay.
Okay.
So there are 2 different colors in a deck, black
Red and
or
black.
red, which means how many cards are red and how many are black?
26. 7, 6,
26. If I have 52 total and I'm cutting them into 2 colors, that means I have 26 of each.
See, I know what I was talking about.
Okay? There are 4 suits in a deck. You've got hearts, diamonds, spades, and clubs. How many are in each suit?
I have no freaking idea.
13.
13. If I have 52 total cards and I've got 4 suits, that means I have 13 of each. In each suit, you've got ace low or ace high, depending on what they ask. The number 2, the number 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Those are your 13 values that you have in each suit. And when they're talking face cards, they're only talking cards that actually have faces on them, or just your jack, queen, king. Everybody somehow wants to put aces in a face card. They are not a face card. There is not a face on it. They are not a face card. Okay. Options.
2 out of 52. No, wait.
We're not trying to do probability. Give me all of the 7s that are in a deck. What do I got?
2.
4, 7.
7 of what?
7 of
Seven
hearts,
of
7 of
hearts,
diamonds, 7
seven
of
of
spades, 7 of clubs.
7 of hearts,
Oh.
7 of diamonds, 7 of spades. Yeah, don't mind my horrible pictures.
I like the nose of the booger.
Sweet.
That was like a piece of broccoli.
Broccoli. As my daughter would say, tree. She likes to eat trees. Okay, so we've got 4 different 7s. We've got a heart, a diamond, a spade, and a club. My sample space size is a 4.
I forgot that.
You forgot what?
I forgot there was one.
Yeah, goofball. Okay. What about a red face card? What are my red face cards? King, queen, and jack. I want them to be red. So, king, queen, and jack of what?
Hearts.
Hearts.
Diamonds.
And then we've got the king, queen, and jack of diamonds. So I've got 6. Pulling a black odd number card from a standard deck. So, black puts us where?
Spades and clubs.
Spades. Oh my God, they just get worse. I love myself.
I'm about to just put S and C.
What's that?
Let it go.
Is that the 8th?
What's it?
Spade. It's a spade and a club.
Spades, clubs. Bite me. Spades and clubs. I'm looking for odd numbered cards. So what does that give me?
1.
Ace.
Ace.
3,
Okay.
6.
They're not going to count the ace because the ace doesn't actually have any number on it.
So 1.
No, B,
2.
there's no 1.
Three.
It'd be
So
3.
3,
3, 5,
5.
7, 9.
7, and 9.
Wait, why not 1?
Because the
Because-
ace is
Oh,
low.
ace.
Ace is technically your 1,
Man,
and they don't
you
count
ace.
that as a numbered card. Okay. So I technically have 3, 5, 7, 9 of spades, 3, 5, 7, 9 of clubs.
So 8.
So 8. Yes.
They had a dream about me and wanted to know how I was
They had a dream about you.
okay. Wanted to know how I was okay. I might have died in their dream.
Oh,
They did thought I died in real
well,
life.
I'm glad you're alive.
Yeah, me too. I didn't know.
Usually I'm the one trying to die in my dreams.
All right. 3 boys and 4 girls are doing a class fundraiser of magazines. Consider how the top 2 sellers could be the same gender. So, in other words, I want 2 boys to win or 2 girls to win. List me out what I can do. And remember, we've got 3 different boys.
So, Jack, Sam, and Alex.
So it'll be.
All right, so you want to do Jack, you said Jack, Sam, and Alex?
We just do one, 2, 3.
That's what I did.
Oh, well.
Okay, so boy 1, boy 2. What else can I have for the boys?
Boy 2, boy 1. Boy 2, boy
Hey,
3.
just
Boy
careful.
2,
We're not
boy
saying first place, second place. We're just saying top 2.
Boy 3.
Boy 2, boy 3.
Boy 1, boy 3.
Whoops. Boy 1, boy 3. Boy 1, boy 3. Okay, so those are your options for the boys.
That B looks like that's a 3.
Listen, because it isn't. That's 3. Let it go.
Talking about the B.
The B that looks like a
Let it go.
38.
Bite me. Okay, so I can put boy 1 and 2 together, 2 and 3 together, or 1 and 3 together. Then we got to do the girls. Girl 1 and 2, girl 1 and 3, girl 1 and 4. What else?
Girl,
I
2
feel like
and
you're
3,
big.
girl 2 and 4.
Girl 2 and 3, girl 2 and 4,
Girl 3 and 4.
and girl 3 and girl 4. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9.
Wait, I'm confused.
Hmm.
No, like,
Did I not?
or you know how you did the boy voice?
Mm-hmm.
So couldn't you do like 1, 2, 1, 3, and then 2, 3, 2, 1, and then 3 and 2, and then 3, 1?
Okay, so if we're talking first place and second place, yes. So Kimberly says, why didn't I switch these and count those as well? We can, but that just means somebody wins first place, somebody wins second place. It's not talking about top 2 sellers. We don't care which place they're in. They just want them in the top 2. They don't matter which order. So if order did matter, then yes, you wanted to go back and you wanted to count 2 and 1 because this would be first place and second place. You'd want to switch this and make this 3 and 2. You'd want to switch this and make this 3 and 1. And count all of those options then. Because if you and I are the top 2, Kimberly, but it doesn't matter that I came in first, you came in second, or you came in first and I came in second, we don't want to double count it. We're just the top 2. Okay. You said you got 10? Oh, okay. I was going to say, please tell me I didn't. So if the order mattered and we were talking first place and second place, how many options would I have? 18. You'd have double the options because you would have to double that. Okay. So it all depends on whether order is going to matter or not.
So it's not 18.
It'd be 18 if we did it, if we flipped all of them. But it's 9 because of what the question is asking.
So in other words, if you and Naiwan were the top 2 sellers, but it didn't matter which one of you came in first or which one of you came in second, there would only be 9 options. But if we want to know Cozy comes first, Naiwan comes second, then there's going to be 18. It's going to have to double. Because there's a difference then between you coming in first, him coming in second, or him coming in first, you coming in second. Okay. Top finisher, Mike, Chris, and Brad are in a race. Consider how they can finish the race assuming that no one ties. Okay, so what does that look like? How many different ways can they finish?
Mike, Chris, Brad.
Mike, Chris, Brad.
Mike, Brad, Chris.
Mike, Brad, Chris.
Chris, Brad, Mike.
Chris, Brad, Mike.
Chris, Mike, Brad.
Chris, Mike, Brad.
Brad, Chris, Mike.
Brad, Chris, Mike.
Brad, Mike, Chris.
Brad, Mike, Chris. There are 6. We got what, 2 more? Bless you.
Oh,
2 more.
She says, oh.
can you go back real quick?
Yes, ma'am.
I'm so sleepy.
Okay. Multiple choice test. Consider a multiple choice test with the answers A, B, C, or D. Consider the possible answers keys that could be made for a 3-question test. Oh my God, it's going to be a lot. So, something like they can all be A. The first 2 can be A and the last one can be B. Or AAC. Or AAD. Oh man.
A, B,
Now we got to go ABA. ABB.
No, I'm not doing
Dun, 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 dun.
Dun, 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 dun,
it.
dun.
Yeah, but I wasn't right.
Nobody's got time for that. Okay, so here comes your shortcut.
This is where you use probability.
Is it 12?
So, listen, on your test, you are going to have 2 problems where you actually have to list out the sample space like we did. They're not going to be huge. They're going to be like the ones we did. Okay, short, sweet, to the point. When you get into stuff like this where you've got a million options going on, you want to use something that we call counting theory. Okay, you did this way back in the day when we talked about, well, not in here, but you did problems like this in middle school. Even in, I teach it in math too. Okay, remember those problems where Sally goes to the restaurant and she has 4 entrees to pick from, 3 desserts, 7 drinks. How many different ways can she eat?
Yeah.
That's what this is. Okay, so you've got a 3-question test. So when we're talking sample space size, we need something for question 1. I need something for question 2, and I need something for question 3. This is what I want. I want 3 questions. Question 1. What are my options for question 1?
4.
A, B, C, and D.
A, B, C, or D? Which Kimberly says that means I've got 4 options. Question number 2. How many options do I have? A, B, C, or D? So guess what? I still have 4. And my last one, I still have 4. So I need an answer for this, and an answer for this, and an answer for that.
So that's 12. 48. 61. 4.
64 different options.
I was not going to write out 64
Right.
options.
We were not about to write out 64 different options.
When will this not be able to be an option? Like
When will what not be an option?
let's
What you
say,
just did.
Counting theory?
yeah,
It will always be an option.
So you can write
instead of it being like that though, it'd be like shorter, like person wise. Person, you can't have
Like for 11.
Like we're about to do with this one?
Yeah.
Hold on, I got you. Okay, so ranking candidates. You've got 5 candidates running in an election. We want president, vice president, secretary. Okay, so this can be something like A is president, B is vice president, C is secretary. I could do ABD. I could do ABE. Okay, this is going to take a million things too. We don't have time to write out all of these options. So we take the shortcut. So the first thing I need to do is I need to pick a president. Then I need to pick myself a VP. Then I need to pick myself a secretary. Okay, so we start with the president.
I'm assuming 5, 4, 3. Oh, no.
Yes. Okay, so when I pick a president, I have all of my candidates here. A, B, C, D, E. I've got all 5 options.
Then you have 4.
Okay. Then Kimberly says, well, my next number should be a 4. Because once I pick a president, they can't be vice president. So it doesn't matter who you take out one of the candidates. So here, now I only have A, C, D, and E. I've lost one. Well, guess what? I lose another one. So then when I get to secretary, there's only 3 people that can be secretary. So 5 times 4 times 3, which is 60. Okay, so when options have to be taken away, your number goes down. Of course there's more.
This says homework.
It does.
Meaning we're done.
So we're done.
Meaning as in, I want to continue on just a little bit more. There's what? 1, 2. Chill. I know. 1, 2. Yeah. We're going to do the next page. So skip the page that says homework. Jump here. We're already into counting theory, so we might as well do the little bit with counting theory. That way tomorrow it's counting theory practice day. Counting theory practice day. Okay. So this is where we're going to use all of our counting theory, and you've really got to think. Okay. So example 1, a bakery sells 4 different soups at lunch and 7 different salads. Consider the below cases and determine how many different lunches could each person order. So Michael goes in and he wants a soup or a salad. So he wants soup or salad. The best way that I know how to do this is to make you visualize it. So this is what he's getting. He's getting a soup or a salad. So once you figure out what he wants, you need to figure out how many. So you go to each one and say, how many soups? 4. How many salads?
7.
Does anybody remember what we use or for in probability?
Whatever.
Subtraction. Multiplication. Addition.
Okay. So PEMDAS. She says PEMDAS. Okay, so me or Ashley or Kimberly. What's my total? How'd you get that?
28.
Add.
I said
That's what's
that.
going to happen here. You said add,
everything.
multiply, subtract,
said
divide.
So you should have said I got one of them right. So I said one.
You listed all 4 operations, so obviously you had one right.
See, that's how I know I got one.
So, or means to add. So, they have a total of
Or
11.
means have. Or
What does subtraction mean? Say.
There is no subtraction.
Good.
It's
What does-
add or multiply.
bet.
Okay, Jared's going in now, and he plans to order a soup and a salad.
Now that's
That's multiplication.
That's multiplication. So it doesn't change the fact that Jared has 4 soups to pick from, and he has 7 salads to pick from, but he wants one of each. So he uses the word and, which means we multiply. So he actually has 28 different options. He can have like the broccoli and cheese with the Caesar salad, or the potato soup with the, I don't know,
Potato salad.
potato salad.
Oh my
Ooh.
god, I'm just,
You're making me hungry. Stop that.
you're right. Potato salad.
Okay, so before we get into the little bit of the rest of this, we need to go over this. Ooh.
Basic counting question.
Basic counting questions. They're gonna ask you to use what we call a digit. Single digit numbers. How many do I have?
10. 9. 10.
You were right to begin with. Okay. So your single digits.
Or 0 through 9.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything, when you look at the keypad on your phone, the numbers that are available are your single digits. How many letters are there in the alphabet?
8.
What?
How many letters are
It is
in-
26.
Oh, my bad.
I was using the question, how many letters are in the alphabet?
And Z.
I was thinking. of the word-
26.
You thought you were smart. Oh, no, I was thinking. of
If
the
I
word-
have to list out the alphabet, I don't know what to say.
But that's what I wrote right here. I didn't. I was thinking-
Okay, the thing that you're gonna have to be careful with when it says alphabet, you wanna be careful whether it's just talking about lowercase letters or whether it's talking about lower and upper. Okay, so if they talk about lower and upper, that changes this to 52. Okay, so just be cautious of that. All right, a pin code. Okay, we've got a pin code. 4 characters in your pin code. So character 1, character 2, character 3, character 4.
Yeah.
Okay, 4 characters. Draw yourself 4 dashes. Consider the below cases and determine how many different pin codes are possible. So in this spot, I want to fill it in with some number. I want a number here, a number here, and a number here. Because it says I'm using only numbers this
Would
time.
it be 10?
10, 10, 10, 10.
So now we fill in the options. Okay, people get confused. They want to put, well, I want a 3 in that spot. It's not what you want there. It's how many numbers can I put there? How many different options? Well, that's why we talk. We've got 10 digits, 10 digits, 10 digits, 10 digits,
40. I mean, damn, I'm doing 10.
10,000
10,000.
different pin codes. There are 10,000 different pin codes. So think about that. When you go to the ATM and you insert your debit card and you put in your 4-digit PIN, there's only 10,000 of those in the world. That's it. 10,000, which is why they're easy to hack. When you don't have a lot of options, they're easier to hack. Okay? 2B. Now, I want to use only letters. So letter, 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 letter. So that changes each one of my options to what? 26.
Phrases.
Okay, 26, 26, 26, 26. Or in other words, 456,976.
That's like 976.
Yes, 976.
4, 5, 6,
976. Okay.
10.
Take a look at 2C and 2D and tell me if you can figure out the difference.
One says only,
letters
one
or
says
only numbers, and one can use letters and numbers.
So what does that mean?
It means that for 2C, you have to do what we did in 2A and 2B and then add those together.
Good. So 2C says I want all letters or all numbers. Well, guess what? I know I have this many options for all letters. So all letters is 456,976. Or all numbers which we know is 10,000. So we would add those together. 466,976. 466,976. Okay, so my password in that one would either have to be ABCD
1, 2, 3.
or 1, 2, 3, 4. Okay, you can't mix them up. In D, now my passcode can have a mixture of both. So that means each spot in my code can be either a number or a letter.
Would that be multiplying?
So think about it. In the first spot, I can put any number I want or any letter that I want.
So you have to multiply 26.
So how many options do I have?
You have to multiply 26 by 10. That would give you the
No.
I don't know. Then never mind. 26 plus 10.
You'd have 26 times 10.
Plus 10.
Plus 10.
36.
So it'd be 36
36.
times 4.
I've got 26 letters I can put in there, or I've got 10 numbers I can put in there. There are 36 different options.
I don't know if that's what it's either.
Okay. So it's up to my options for each one to 36, which means I've got 1,679,616 different options. So the more you can add in, the harder it is to crack, which is why most of you are getting emails from whatever service you use now, Gmail, the school service, where it says your password has to contain a special character. It's got to have an uppercase letter there. It's got to have this. It's got to have that. It, as much as it makes you angry, the more basic your password is, the easier it is for me to take it and steal your identity. I'm going to tell you right now, I've had my identity stolen. It sucks. It sucks. Okay. So again, it's a pain in the butt, but okay. Example 3, a student password must contain 5 characters. So I need character 1, 2, 3, 4, 5. Okay. It says my password must start with a number. So I have to have a number there. Nothing else can go there. Does it say anything else about the rest of them? No. Which means for the rest of them, I can have a letter or a number.
Or special characters.
We're not getting into special characters. That would drive us up a wall. I couldn't even tell you how many special characters there are. Okay.
It would be 10 times 36, 36, 36.
Yes. So when I'm reduced to just numbers in this spot, that only gives me 10 options. When I expand it to letters and numbers, that makes all of these 36 options. So we've got, I don't have that one in my notes. Oh, I suck. Somebody want to multiply that? I thought I had these done. Oh.
16, 796, 160. I'm pretty sure.
You said what?
Yeah, what was that?
16,796,160.
116.
60.
Oh, 60. 160.
Well, her fault for you not being loud.
16,796,160.
And you just cussed like that. Shit.
Right.
Sorry.
Bad. Okay. C. Oh, wait. Let's jump down to B. Okay. I'm still talking about a 5-character password. That hasn't changed. So I still need 5 characters in my password. This time, I want to start with a number and end with a letter. Again, they don't tell us about anything else, so we're going to assume that I can use a number and a letter. So So my first character in my password has to be a number. Options. 10.
36.
36 for your numbers and letters.
27.
And only 26 options when I want to put in a letter.
12,130,506.
12 million, say that again.
130,506.
560.
60, not 16.
So just by changing that last one and tweaking it just a little bit, look how many options we got rid of. We got rid of over 4 million different options just by reducing that last character of your password to a letter. Okay? What if I had a password where all I told you was my last one had to be a letter?
It'd be 436. 436s.
Okay? 436s and a 26. Because again, these ones could be numbers and letters then.
43,670,000.
670,000. 16.
Yeah.
Oh, this is a whole page.
Oh, we don't have like 2 more examples. That's just words of what we talked about already. Calm down. Oh.
Still a whole page.
Okay, so, zip it. All right, 2 basic rules of counting theory. We've just talked about these, but I wanted to give it to you in words so you have something to reference. When we're talking multiplication, it's and then. So and means multiply. When you're talking sum, we're looking for the word or. This or that. Okay? That's all it says. All right, so Roger's packed 4 pairs of shoes, 6 pants, 7 shirts, 3 jackets for a week's vacation to the mountains. How many different outfits could Roger wear if he plans to wear shoes, pants, a shirt, and a jacket? So, listen, I gave you this chart just the way I used to do. I was drawing the lines, okay? So, we want to get shoes for Roger. Roger also needs pants. He then needs a shirt. And it's cold outside, so he wants a jacket. Okay, and again, now we've got to talk options. He's going to pick a pair of shoes. How many options? 4. And he's going to put on some pants today.
6.
And he's going to put on a shirt today.
7.
And he's going to put on a jacket.
3. 504.
There's 504 different outfits he can make out of what he brought. Now, nobody said that he would match. Okay. But there's 504 different ways that he can put some clothes together. Number 2, you're going to a diner that orders 4-course meal. You get an appetizer, soup, entree, and dessert, in addition to a drink choice. How many 4-course meals could be made from this menu? So we want 4 courses. So we can get an appetizer, and we're getting soup, and we're getting an entree, and we need some chocolate, so we're getting some dessert. And of course, you need something to wash it down with. So we're also going to get a drink.
Five, 3, 9, 6, 11.
5 and 3 and 9 and 6 and 11.
8,910.
8,910. 2 more. Got this. Okay. Think about how this is going to change it now. How many different meals include an appetizer or dessert? So we're still getting the soup, we're still getting the entree, we're still getting the drink, but now instead of getting an appetizer and dessert, I want one or the other.
For an appetizer, it's 1,485.
Okay, so you went soup, entree, appetizer, drink. Okay, so Ashley said that's 3, and then 9, and then 5, and 11, which was what?
1,485.
485. Okay, so that's just an appetizer. Or we can get dessert. So then we've got soup, entree. Instead of an appetizer, we're getting some dessert and a drink. So now my options change from 3, 9. Now we've got 6 and 11.
1,782.
1,782. Add these together to get my final. So that's a 7, 6, carry the 1, 2, 3,267. Okay, there's one other way you could have handled this.
You did the 8, 9, 10.
Okay, so the last way you could have handled this, because Ashley's way is absolutely correct. There is nothing wrong with the way that Ashley did it. But some of you may think otherwise. I will show you the other way. So we can get a soup. We can get and an entree, app or dessert, and a drink. So I still have 3 soups. I still have 9 entrees. But when I get to this point, app or dessert, I've got 5 apps to pick from, 6 desserts, which means I have 11 options. So instead of splitting it and doing it separately and then adding them together, I can add it here and it will give me the total to begin with. So 11 drinks, and guess what? You still get 3,267 different options. Okay, so those are the 2 different ways you can do it. I don't care which one. I don't. Because guess what? Same answer.
I feel like that would probably confuse me. Separating.
The way I do it, see, I do it the second way. I do all of my ors first and get those total numbers, and then I multiply everything through.
Separating it because it makes me see that.
Whatever works for you, I am not against. Okay, last one. An NFL team has enough room on their roster to sign 2 more free agents and must make the choice from 3 quarterbacks, 4 linebackers, 5 wide receivers. How many different ways are there to pick 2 players if they must play different positions? So, player 1, player 2. What can I pick? 2 different positions. So I can pick a quarterback
And then linebacker.
and a linebacker. Okay? So I've got 3 options, 4 options. That gives me 12. What else can I do?
You can do QB and wide receiver.
QB and a wide receiver. So that changes my options to 3 and 5. There's 15 different ways that I could pick a QB and a wide receiver. Linebacker and a wide receiver. And I've got 4 and 5. There's 20 different ways. So what's my final answer then?
20 plus 15 is 12.
We add all these up. There's 47 different ways that I can pick a linebacker, a wide receiver, and a quarterback in 2 positions. questions? So there was a short homework assignment for 15.1. There's also a short homework assignment for just this introduction at the bottom of this page. All of your homework is in this packet. Please do not do it in the packet. Do it on a separate sheet of paper so it can be turned in. Okay. So you've got the 1 through 4, and then I do believe it's 9, 10, 12, 14, 16. Is that what's
So,
on there?
yeah, this
Yeah.
one. And then-
Yes. So, in other words, and yes, these are my answer keys. So in other words, this page that says 15.1 homework, and then you're doing, oh, I don't have that one in here, 9 through 16 at the bottom of that page. Okay, I was just gonna show them. At the bottom of this page, you've got your 15.2 homework. Okay, separate sheet of paper, please. Tomorrow we are going to spend the period practicing counting problems and talking about permutations and combinations. Yes, ma'am.
Oh, that's cool.